All right, so we have the generally jumping over the riverbed. Okay, and when it takes off, okay, here is what we know. We know that it takes off at 32 meters per second at an angle of 20 degrees above the horizontal. Okay. When it flies across, it's going to do this. It's going to encounter the other side of the river, same height as the launch point. Okay, so what's the total vertical displacement from one side to the other? 0, right? Okay, it ends up at the same height it started. All right, we're looking for two things: the horizontal distance and the maximum height the generally will reach above the river. Okay, we haven't done a maximum height one yet, but we have done a distance across. Okay, so here's how we do any projectile motion question that involves something launched at an angle. First thing, we break it up into its vertical and horizontal components. What's the only piece of information those two parts share? Time. Okay, the time is the same for both the horizontal and the vertical. Once the generally crashes to the ground on the other side, it is doing neither one of those things anymore. Okay? All right, so vertically speaking, or actually before we even get to vertical, okay, let's have a look at what this looks like in terms of vector components. The 32 meters per second is directed 20 degrees above the horizontal, which means it has a horizontal component that will be the constant horizontal velocity of the generally as it travels through the air. That's not going to change. It's going to be constant throughout. Okay? Could I calculate that number right now? Yes. Okay? I know the hypotenuse is 32. I know the angle is 20. I'm looking for the adjacent side, so I would go cos of 20 times 32 meters per second, and I will get how fast the generally is traveling horizontally through the air. All right, so we're going to have cos of 20 times 32. Okay, so we got 30.07 meters per second. So still pretty fast. All right, the y component of this represents the initial vertical velocity of the general leap. Okay, so at time 0, at the instant the generally leaves the ramp on that side, this is how fast it's moving up. Okay, this is how fast it's actually going, 32. Okay, but the up part is the component we're worried about for the vertical information. Okay, since it's the opposite side, we'll calculate it by going sine of 20 times the hypotenuse, 32. So here's something that you need to make note of. This 32 never gets used for vertical or horizontal speeds. Okay, but that's a very common mistake that I see. People start doing acceleration calculations using 32 meters per second. Or they'll say that the horizontal speed is 32 meters per second. It's not. You're only using that number to get components. It will never be part of a v equals d over t or acceleration calculation in a projectile motion problem. Okay. All right. So sine of 20 degrees times 32. All right, 10.94 meters per second. Okay. So now, the generally flies through the air, lands on the ground over here, at the same height it was launched from. So, what's its final vertical velocity? Right, 10.94 meters per second down. Okay, it's going up a certain distance and coming right back down that exact same distance at the same rate of acceleration. So VI and VF are always equal, provided the final height and the initial point are the same. Okay, so if it's just doing this arc, then VI and VF are the same. Okay, and that's because the displacement is, the vertical displacement is 0. Okay. Okay, so now we've got that. Okay, what other thing do I know vertically that I haven't written down yet? Acceleration. Okay, so my acceleration vertically is negative 9.81 meters per second squared. Okay, or down, but not both. Okay, I'm supposed to find two things in this question. I'm supposed to find the horizontal distance and the maximum height that the generally reaches. Okay, since we haven't talked about the maximum height stuff yet, let's move on to this, finding the horizontal distance. Okay, since I know that horizontally, the horizontal velocity is not going to change, I use v equals d over t for all my horizontal stuff. So what am I missing? Time. Can I find time with these three pieces of vertical information? Yes. All right, so I'm going to find the time by going VF minus VI over A. So just manipulating our science 10 acceleration formula for t. So that'll be negative 10.94 minus 10.94 divided by negative 9.81. So I'm just going to take that number and multiply it by 2 and then divide it by 9.81. And it's the same thing. All right, so the general E is in the air for 2.2 seconds. Okay, it takes 2.2 seconds for it to cross the river through the air. Okay, 2.2 seconds. That number can come over here. Because it's the one thing the horizontal and vertical parts share. Okay, now that I have that, now I can calculate the distance across the river by manipulating v equals d over t for d. Okay, so we're going to have our 30.07 multiplied by 2.2. Okay, and we'll use all of our decimals here. We're not going to round anything off, so we'll take that number and multiply it by that number. Okay, it's 67 meters across the river. So the general E flies through the air 2/3 of the length of this straightaway on the track out back. Okay, that straightaway is 100 meters long. 2/3 of it is the distance that the general E flies through the air. Okay? It's a considerable distance. Everybody follow how we did that? Okay? That's a very, very typical projectile motion question. Okay? The most common type asked is, here's some information, how far does it go horizontally, and now, what's the maximum height? Okay, so if we're looking at maximum height, I'm going to go back to our diagram here. Where does the maximum vertical height occur? In the middle, right, at exactly halfway. Okay, that will be my maximum vertical, sorry, I should do it in green because everything vertical has been green up until this point. Okay, just to match here. Okay, so my maximum vertical displacement occurs at exactly the halfway point of my flight. How fast is the object going vertically at its maximum height? Yeah, 0. Right? If I throw this marker up in the air, when it's at its maximum height is that point where it's stopped and turns around and starts falling back down. Okay? So something we need to just remember is that at our maximum height, VF is 0 meters per second. It's an added little piece of information. Okay? We don't even have to calculate it, we just have to kind of understand how an object flying up in the air would be at 0 at its maximum height. What's something else that's going to change that I calculated already for the maximum height? Time. Time will be how much? Half. Okay? Because this occurs at exactly halfway through the flight. Okay? Now this is why I typically show people one way to do this and I don't show them the other way. People, when they're doing this and using time, inevitably forget that D occurs at half the time and they forget to divide their time by 2. Okay? And then when they do that, they get the wrong answer for the vertical displacement. Okay? They get 0. Because if you use the full time, that's what the displacement will be, 0. Okay? All right. So what we're going to do here now is we're going to look at what we have. I'm looking for D. I have VF. I have VI. This still applies. Okay? And I still have the acceleration. So is there a formula that has acceleration, VF, D, and VI in it? This one. If you recall, when I taught you this formula back when we were doing acceleration, I said that one gets used all the time in projectile motion. Here's where. Okay? I don't need the time for this one. I don't have to remember that this occurs at halfway through. Okay? Time is irrelevant for this formula. So now I'm just going to solve for D. So that'll be VF squared minus VI squared divided by 2A equals D. Okay, so for this one, that'll be 0 squared minus 10.94 squared over 2 times negative 9.81. It's important to have the negative in there, otherwise your answer will tell you that this thing went into the ground and burrowed a deep hole. Okay? You get the right magnitude, but not the right direction. All right, so now that I've got that, okay, now I can punch that into my calculator. And it's important to keep the 0 in there. Oh, shoot. I just deleted my numbers.
Can't you go this roll?
I don't know that I... Oh, I can. Oh, awesome. That was lucky. Okay. So I need that number there. Okay, so I'm going to go... Okay, so I'm going to have 0 minus, okay, my 10.94 squared, okay, divided by 2 times 9.81, so that'll be negative 19.62. All right, so the general E is going to reach a maximum height of 6.1 meters. That's over 20 feet. It's the equivalent of dropping the general E off the top of the gym. How well is that going to work out? Not well. And that's just dropping it. That's not taking into account the fact that it's flying through the air horizontally at 30 meters per second. Okay? There's a lot of energy involved here that can do a lot of work on the general E and make it a big orange mess. Okay, on the other side of that jump. Okay, so that is a very typical example of a projectile motion question. I cannot remember the last time I didn't have a question just like that on both the unit and final exams for this course. Hint, hint. Okay. I want you guys to try this one. Basically like what we just did, okay? Yeah. All right, so you got a cannonball fired at an angle of 40 degrees above the horizontal at a speed of 140 meters per second. How far does it travel? What is its maximum height? Okay, you can look at your method from the last question. It's going to be very similar to this one. It's just got different numbers. Okay, so basically exactly the same as the last one. We got a cannonball fired, okay, 40-degree angle. Okay, and 140 meters per second, not a very fast cannonball. Okay, going to follow an arc down to the other side here. Since we're not told otherwise, we assume launch and impact points are at the same height. Okay, so our overall displacement is 0. Right, we're looking for how far it travels, okay, and its maximum height. So vertical information, horizontal information. Okay, so we have to remember, okay, that this is the constant horizontal velocity and that this side is our initial vertical velocity. That is just something you have to remember. Okay? There's not a lot of things in physics you have to memorize. That's one of them. Okay? It's just that that's how that triangle works. Right? So my initial vertical velocity will be the sine of 40 degrees times 140 meters per second. Sine of 40. So we're looking at 89.99 meters per second. So what does that mean VF is? Same but negative, right? Okay, if we're talking about the whole trip. If we're talking about the maximum height, which we will be in a minute, it will be right. Okay, and then our other piece of information here is acceleration is negative 9.81 meters per second squared. All right, since we're at this point, we're working with the vertical information, what can we calculate right now that we always need? Time. Okay, so time is going to be VF minus VI over A, so that'll be negative 89.9 minus 89.9 over negative 9.81. Okay, so we're going to take that number, multiply it by 2, and then divide it by 9.81. Okay, so we got 18.3 seconds for our time. Okay, that I'm going to bring over here, because it's the one thing I can. And then I'm going to calculate, this is all supposed to be in red, okay? Now I'm going to calculate V horizontal. Okay, it is the adjacent side to my 40-degree angle, so that'll be cos of 40 times 140. All right, so looking at 107.2 meters per second. For our constant horizontal velocity. Now that we have both of those things, we can now calculate what the horizontal distance traveled will be, V times T, so that 107.2 times 18.3 seconds. All right, Cannonball travels almost 2 kilometers. Okay, in fact, when we round it to 2 significant digits, it is 2 kilometers, okay, for the horizontal distance traveled. All right, now I've got to calculate the maximum height of the cannonball, which we know occurs here. What's VF at this point? 0. All right, so I'm going to calculate VF. Okay, so I'm going to calculate D using this formula. VF squared equals VI squared plus 2AD. But then I'm going to show you that this formula will also calculate it. It'll give me exactly the same number, provided I do what? Well, actually, that's under the time VF in it. Cut the time in half. Yeah, that's the key. I can use that formula, but I gotta cut the time in half. Okay. All right. So first we'll use this one. D will equal VF squared minus VI squared over 2A. Okay, so that'll be 0 squared minus 89.9 squared divided by negative 19.62. Okay, it's 2 times 9.81. So if we do it that way, we'll take our that number there, squared, and we'll just divide it by 19.62. If I make them both positive, it's the same thing. Okay, 412 meters, so 4.1 times 10 to the 2 meters. Okay, does it follow a long way?
So I put them in brackets and I got like 4.6. So
What'd you put in brackets?
The final equation is 0 squared times.
Okay, so you went 0
No.
minus.
No, like 0. I put like bracket 0 squared.
Okay, 0 squared minus. Did you remember to put the bottom in brackets?
Probably didn't keep your whole answer.
If you round it off, that could be the difference. Because I mean you're squaring it, right? If you round off a number and then square it, it's much different than if you keep all the numbers and
I
square.
didn't square the other.
That would be it. Okay. Now, the other formula we said we could use, this one here, D equals VI times T plus 1/2 AT squared. All right, so we're going to have our 89.9 times half the time, so 9.15 seconds. Okay, but we'll actually get the real number there. Okay, plus 1/2 times negative 9.81 times 9.15 squared. Okay, so we're going to get those numbers here. Okay, we're going to find the time here and divide it by 2. That number there. Okay, divided by 2. All right, so now we've got our half of our time. We're going to multiply that by our 89.9. Back up and get that. Okay, equals, all right, plus 0.5 times negative 9.81 times that number there squared. So I get exactly the same number, still get 412 meters. I just have to remember that I got to divide the time by 2. So there's more than one way to find your maximum height. I just find people mess that way up because they forget to divide the time by 2. Okay? They're less likely to screw it up with the VF squared formula because they don't have to worry about time. Okay. Everybody with me there? All right. I'm going to show you another video for the